Alright, here we're going to be going over the problem from our mock exam. This is going to be problem 10, where we have different failure criteria using differential stress and strain. We're going to be plotting it up on our Moore diagram and figuring out the failure envelope. So to do this, in our graph, which you guys will have to be looking at this to see it, this is how we plot it. So our first PC, that is going to be our confining pressure. When that equals 0, PC is actually our sigma 3 value, right? It's the value, it's the minimum stress value. It breaks at that value. So our confining pressure is our sigma 3. So PC for our first experiment is 0. If you look at the differential stress, at the moment that our sample fails, right, where the graph starts to go immediately straight down, that is going to be our sigma 1 direction. So if we start at 0 for the first circle, and then if we look at our other graph, it's about 130, so 120, 130 for our sigma 1. You go through and roughly figure out the halfway point. Draw your failure, your circle. And that is your first circle. Your next failing experiment, your confining pressure starts at 100, and your differential stress ends at about 290, but because we're starting at 100, you go up to 290, so 220, 240, 260, 280, 290, and you add 100 because we're not starting at 0, we're starting at 100. So you go to 390 instead, and that is your sigma 1 that you have to determine your radius from. So I'm just doing this quick. Ideally on the test, right, you'll be doing something similar to this. You could also calculate it out. But for a rough circle, there is our second Moore circle. Alright, on to the next one. We have a confining pressure sigma 3 of 200. Look up on the graph. It's got a differential stress of about 420, 440, 460, 470. So you go up to 470, so 20, 40, 60, 70. But again, we started at 200, so you add 200, so 570, 670. And that is going to be, right, our new parameters. So you can't see it from here, but again, I'm going to find that circle, the radius of our circle, so we can draw this guy. And our final one, right, we have a failure PC of 330, so 320, 330. Our differential stress is about 530, 520, 30, but we have to add 330, right? So 630, 730, 830. And then add 30 to that, so about 860. Again, I can't zoom out very well with my setup here, but about finding the middle point for this. Right here. And drawing a circle. Oops. Just a little off, but close enough. All right, so to zoom out, because you're going to see my apparatus a little bit, we have all of our circles here. What I'm going to do now is go back to here, and you'll notice our fourth circle is a little bit smaller than the other ones, which will come into play in a minute. But for these, since these are all for the most part lining up, right, you find that tangential point that is about the same on each of them. All right, we're going to draw a line connecting them. And that gets us to here, which is our failure envelope of about 40 megapascals. Right, that's the beginning of our failure envelope. Any tangential point on these three circles is going to be our actual failure angle, which then you can figure out here, again, by going to your origin of your circle, looking up the radius, which is about 58 degrees. You go from the center here and read up. So your failure is usually at 58 degrees in this particular setting. And then talking about what our fourth and final circle represents, right? This is our transition from our Coulomb failure criteria into our von Mises criteria. So we are starting to get our plastic deformation, and we're seeing the transfer from that. So that is how you do this problem in our mock exam